Hello, my name is Marijn van Vliet and I'm a research software engineer at Aalto University in Finland. Throughout my career, I've seen a fair amount of data analysis pipelines. And it occurs to me that there is a common set of problems that all these analysis pipelines must solve. Problems like, how do I run only part of my analysis pipeline? And how do I run my analysis pipeline over multiple subjects? And everyone seems to be reinventing solutions to the same set of problems, unaware that good solutions already exist. So, today I'm going to show you some very good solutions, so you can finally stop reinventing the wheel and just get on with your research. So in case you haven't noticed yet, this is going to be a highly opinionated talk. Much of what I'm going to teach you is how I think things should be done. And you may disagree and think you have a better solution. And that's okay. It's okay to be wrong. I invite everyone to write down their opinions in the chat, and after this talk, let's discuss together. I have a little EEG data analysis pipeline, which we will use as an example. Unlike your code, which is probably hundreds of lines of spaghetti, this example is small enough to fit on a single screen and we can wrap our heads around it. For educational purposes, we're going to treat this thing as if it were a large, complicated pipeline. So, let's run it and see what it does. See, it loads some data, does some pre-processing on it, and makes a pretty plot. For those of you who are interested, this is a part of the Brainvaders dataset, which is a P300 oddball experiment. And the plot you're looking at is the event-related potential of a single subject. Now let's discuss the first very common problem we encounter. We want to run only part of this analysis. Say I'm unhappy with the way that epochs are cut. Epochs are little segments of EEG data, and I feel these are too short. I want to play around with how long these are. For example, I want to change this to 1 second. Now, of course, I want to run this to see what effect it has, but I don't want to rerun all of this. Remember, we're pretending that this is a large pipeline and this will take minutes or even hours to run. I just want to run this part. So this is how I see many of you do solve this. We select all of this and we comment it out. This works, but it is a terrible idea because now I go on vacation and I come back a month later and I see my script in this state and I have no idea what's going on anymore. Was this code wrong somehow? Why is this commented out? It's no longer really running when I press run. Terrible idea. No. Instead, what we're going to do is we're going to cut up this script into multiple little scripts. So we can run each script in isolation. So now it has been split up into 4 scripts. Each script starts with the loading of the data, then doing the preprocessing, and then it ends with saving. So this way we can run each script in isolation and it becomes super easy to just run a specific step. What did we want to do again? We wanted to change the length of the epoch. So I can now just go ahead and do that. And now I just run the epoching part again. There it is, quick and easy. If you want to change it to something else, we can do that and just rerun. Super quick. No commenting out required, no if statements required. Now to actually plot it, and now my epochs are a little bit longer. This is the part where you say, now hold on a minute. Now if I want to run the entire pipeline, I have to run 4 scripts. This takes way too much time. This is why we are going to write a master script. One script that will run the entire pipeline. Now, what should I use to write this in? It can be a bash script, but I'm running this on Windows. It will not run on my machine. So should it be a Windows batch file? No, because then it will not run on Linux. Should this be a Python script that runs the other ones? That's a good possibility, but I will do you one better. We will write this as a Python script, but we will do it using the Do-It Workflow Manager. I've tried now many different workflow managers. You have Makefiles, you have SnakeMake, you have NiPipe, and none of them are as easy to use and well suited for the task as Do-It. So this is how it would look if we just have a single script. We define a task in Do-It, and we do this by writing a Python function that returns a dictionary. First component is the files that are needed to do the task, which in this case is the Python script that we're going to run, and it is the data that is being read by the Python script. Next, we specify all the files that are produced by this task, in this case, all the files that are written by our analysis. And finally, we write what commands should be run in order to do the task, which is run Python on this analysis. And this is how it looks for the other 4 scripts. So now that we have this set up, we can go to either our command line or Python terminal and ask Do-It to list all the tasks that we have defined. You can see that all the steps of our data analysis pipeline are here. And of course, we can now tell Do-It, run the entire data analysis. Done. And now I want to show you a bit of magic. Because we told the workflow tool for each script which files it reads and which files it writes, when we run this again, the workflow tool can tell us that all the steps are completely up to date and there's no need to run anything again. So say we want to go back to work on our epochs. Say, okay, I actually don't like half a second. I will change it back to a complete second. And now I tell Do-It, okay, run everything again. And it will detect, wait, this epoch script has changed. The rest has stayed the same. So I can skip the first 2 steps. I only have to do the epoching part and I have to do the computation of the. And this is really the best way to be running an analysis pipe. You can now quickly run any part of it that you want in isolation, and you can very efficiently run the entire thing because it will never do unnecessary work. And I really hope you're not too intimidated by this workflow configurations. Once you've worked a little bit with this and see how it works, I promise you, you will fall in love with this. Now, let's talk about something else that I see everybody struggling with. Parameters. Where do you define them? As a base rule, I would say you define the parameters, for example, the cutoffs for this bandpass filter. You define them right where you call the function for bandpass filter. Generally, I like to keep the definition of the parameters as close as possible to where I actually use them. So in this case, that would be inside the function call itself. However, there's an important exception to this rule, and that is when a parameter is defined in multiple analysis scripts. And in this small analysis pipeline, there's one such parameter that we use all over the place, and that is the subject number. There is one thing that we should never ever do, and that is copy-paste the value of a parameter all over the place. And that is exactly what I have done with the subject number. So what happens when we want to run this analysis pipeline for another subject? I have to change it here, I have to change it here, I have to change it here, I have to change it there. And did you just spot the mistake I made? I forgot to change it in the first script, and when I run this, I will never notice. So this is why we never copy-paste parameter values. Parameters that are used in multiple scripts go into a configuration file. We have a separate file, which I always call config, and there I define all my parameters that are used across multiple scripts. So in this case, we have the subject number, which is, well, let's set it to 2. So now we go through all the scripts that need the subject number. And there we say from config import subject number. So now I changed the subject number to the variable. And I do this in all the scripts where it is used. All right, next super common problem. How do I run this analysis pipeline on more than one subject? This is the solution I see most of the time. We just write a for loop. We have 4 files, so I should copy paste now this for loop all over the place. And this is terrible, isn't it? Because now I can't run it on a single subject anymore. So if I'm working on some part of it and I just want to test it on a single subject, I lose this ability. And now what I see often done is people start doing this. I want to run it only on the first one, so we're just gonna do it like this. And then, well, actually, so now I need to run it on 4 and maybe 5. And this crap just keeps piling up and it's just horrible. Stop doing this. I'm gonna show you how to do it better. Here is how you should actually do it. We are going to bring in the subject to process as a command line parameter. There. Now, when we run this script, it will tell us we need the subject as an argument. So now I can run any subject that I want. But I want it to run for all the subjects. So for this, we go back to our master script. So first we're going to need the subject list. And then we're going to split up each task into a subtask for each subject. And you do that like this. You loop over the subjects. And instead of returning a dictionary, because that would break the loop, we yield dictionary. So we do this for all our scripts. And now we replace subject 1 with a value that's not hard-coded. And well, before, our single task would get its name from whatever we defined the function name to be. With subtasks, we actually must give it a specific name. And of course, we must pass in the subject as a command line parameter. So now that we have set this up, we can go to our Do It tool and make it list all the tasks, including the subtask. And you see we now have a subtask defined for each subject. So now we can run the entire analysis pipeline, all the steps on all the subjects. Boom! But we haven't lost the ability to run a single step on a single subject. You can also do that through the Do It toolbar. So now the days of commenting out subjects like this are over, hopefully. I understand that a workflow manager may be quite intimidating at first sight, but I really recommend that you try using one. They are the tools specifically designed for running this type of analysis pipeline, and they will help you out a ton. Onwards to the next common problem, and that is file names. So when you follow all of my advice, file names suddenly become a nightmare to you because we define them all over the place and they have parameters inside them that you need to set. And they become long and they become messy and they become horrible. What are we going to do with them? Inside the configuration file, we are going to make a list of file name templates. And I like to write them down like this. I make first a little namespace called fname, and inside of there, I'm gonna put templates for my file names. So here is the original data. And now this subject is going to be Python placeholder. And we have raw file in MD Python format. We have the filtered data. We have the epochs. Let's call it. We have the evokes. There. Now, whenever I want to use a file name, I just go from config import fname, and I'm going to use it here. So now instead of this entire thing, I can just say fname, original file, and of course I must fill in this subject placeholder. That is quite a bit neater. And here I can do the same thing. Now, I don't really like this dot format syntax. Ideally, I would like to write it like this. I think that's just a little bit neater. So I went ahead and wrote a little utility clause for it called file name templates, and it just provides a tiny wrapper around what I just did. There. And now here we can write it the way we want, so we can get rid of this format. And this is especially useful here in our master script. Look how well this all cleans up. It is so useful to have a complete list of all the file names that are relevant in this analysis pipeline in a single place, because I can quickly see that they are all correct and they are consistently named. Now that I look at this, this really shouldn't have filtered in a name again. So I can just get rid of that, and I can be confident that the entire analysis pipeline will use the new name. So, to summarize, we've seen 4 very common problems that almost any data analysis pipeline in neuroscience must solve, and I've shown you my solutions to these problems. If you want to read the code at your own leisure and read more about this, the link to the code repository of this talk is here below, and hopefully you will never have to struggle with any of these problems ever again.